Alright, in this video I'm going to be explaining another important paper with the title Random Propagations in Graph Neural Networks. This paper in 2024 by University of Cambridge. Graph learning benefits many fields. However, graph neural networks often struggle with scalability, especially on large graphs. At the same time, many tasks seem to be simple in terms of learning. For example, simple diffusion yields favorable performance. So we present random propagation, a framework that addresses two main research questions. Can random propagation in graph neural networks be as effective as end-to-end optimized GNNs? And can they reduce the computational burden required by traditional GNNs? So how effective is random propagation across various datasets? Can random weights requiring only the final classifier to be trained serve as a viable alternative to current methods? So we introduced this RAP GNN. This RAP GNN, you see the framework here that we employ L-layer GNN with randomly sampled GNN weights as defined in equation 1 instead of learnable GNNs. Paired with either a pre-trained or learnable MLP. So the model consists of three components: an embedding layer, a stack of GNN layers with nonlinearity, and a classifier. The embedding layer maps input feature dimension P into a higher dimension D using MLP. The embedding layer is pre-trained on a dataset for a downstream task using a simplified network. In the training phase, the key innovation is introducing randomness into GNN network, which consists of L hidden layers. During each forward pass, a new random diagonal weight matrix is sampled for each GNN layer. So you see that alpha is sampled from a uniform distribution. And during backpropagation, in this training phase, only the parameter theta of the classifier are updated based on the loss function, while W and phi remain unchanged. So significantly reduces computational costs. And during inference, majority voting is employed to enhance robustness and generalization, with the number of votes, M, treated as a hyperparameter. And they did experiments on datasets like Cora, CiteSeer, PubMed, OGB, and Archive. So they initialized the model, then a pre-training phase for edge. We initialized rate, maximum epochs, and pre-training process. Then we compute loss for ground truths y and y hat. Then update using gradient descent. And this is for evaluation part and training phase.